Welcome to Homework Lib.
So over here for the following free radical reaction, we're going to identify the initiation, termination, propagation, and termination steps. So first of all, in the initiation step, what we're going to have is that the chlorine, with all of the pair of electrons, is going to generate a radical on the presence of H nu, of UV light in this case, which is going to generate two of the chlorine radicals. Next up, we're going to proceed with the propagation step. In the propagation step, we're going to look for the most stable radical in our organic molecule. In this case, it is going to be a tertiary radical that is going to be residing on this position. So what is going to occur on the propagation step is the following. We're going to have our cyclohexane with the ethyl group over here, and we have an hydrogen on this position. What is going to occur is that we're going to draw this half arrow. Remember that the half arrow represents the movement of a single electron, opposed to the regular arrows that represent the movement of two electrons, plus the Br in order to produce the radical on this position. Over here, just to be able to differentiate, I'm going to write down the electron for the radical in red and our ethyl group. The next step of the propagation is going to be the reaction of that radical with its electron with the other bromine radical that we have present on the mixture. Recall that we have generated already two bromine radicals. So now we're going to write down the half arrows in order to generate the halogenated product. Half arrow here, half arrow here, which produces, here a small correction, this is going to occur in between with another bromine, just to have the last step occur for the termination. So over here what we're going to have, remember always to write down all of the pair of electrons, and one half goes here. This is going to produce the following molecule. We're going to have our ethyl group over here and our bromine atom plus another bromine radical. All of this is going to be the propagation step. And finally, the termination is going to correspond to the reaction in between two bromine radicals. Here, let me just add the byproduct, which is HBr. And for the termination, this reaction is going to produce Br2. And with that, it would be all. In this case, I just realized that I was writing down the mechanism with Br since it is more common to use bromine instead of chlorine. So over here, let me just replace all of the bromine atoms over here. This should be all of them chlorine atoms, of course. Chlorine, HCl, chlorine, chlorine, and chlorine. Sorry, just got it out of a custom of the normal reagents. Now it is correct. The two chlorine are going to get together in order to generate Cl2. And now with that, it would be all. Thank you very much and have a good one. Remember that for the termination step, you can add any pair of free radicals that are going to react with each other in order to cancel out. In this case, I'm just following the normal stoichiometry. We're going to have two chlorine radicals. We're going to use one over here, generate a new one. We're going to end up with two, so the two are going to combine for the termination step. And with that, it would be all. Thank you very much and have a good one. Also, I'm just considering the main product of the reaction. Recall that over here, you're going to be able to have different side reactions since this is a free radical reaction. And with that, it would be all. Thanks and have a good one.